This question is about time of flight mass spectrometry. Give the equation including state symbols for the formation of Sr plus ions from Sr atoms by electron impact. So high energy electrons are fired at the sample, so you could either add an electron here. I just prefer to show the ionization, so just knock off the electron. If you want to add an electron to the left, because high energy electrons fired from an electron gun, you would need to have 2 electrons on the right. A sample of strontium is analysed by time of flight mass spectrometry. The sample is ionised using electron impact. The ions are accelerated to have a kinetic energy of 7.02 times 10 to the minus 20 joules, and they take 9.47 times 10 to the minus 4 seconds to travel along a 95 centimetre flight tube. Now the flight tube distance, we need speed in metres per second, so I'm going to change this to 0.95 metres. There are 100 centimetres in a metre. So the first thing I'm going to do is work out V by doing D divided by T. So 0.95 divided by 9.47 times 10 to the minus 4. So I'm going to put that on my calculator, use the fraction button, 0.95 on the top line, 9.47 times 10 to the minus 4 on the bottom line. That's 1003 metres per second. We've got to get the mass number. So the first thing we're going to do is rearrange the kinetic energy expression to give us mass. So 2ke divided by v squared, but this is going to be the mass of one ion and not mass number. Going to be the mass of one ion in kilograms even. So 2 times the kinetic energy divided by the velocity we've just calculated squared. So again, I'm going to use the fraction button, top line, 2 times 7.02 times 10 to the minus 2. And on the bottom line, I'm going to insert the answer and square it. So I'm keeping the number on my calculator. 1.395 times 10 to the minus 7 not minus 7, sorry, times 10 to the minus 25 kilograms. So then I'm going to multiply by 1,000 to get it into grams. 1.395 times 10 to the minus 22 grams. Now that's the mass of one ion. So I'm going to times by Avogadro's to find the mass of 1 mole. And I'm getting 84.01. Now that's not a mass number, because mass number is number of protons plus neutrons, and so I need to give a whole number answer because this is mass number. Explain how ions are detected in a TOF mass spectrometer and how their relative abundance is measured. So when the ion hits the detector, gains an electron, this generates a current at the detector. The size of the current generated is proportional to the abundance. A sample of strontium contains 3 isotopes, 86, 87 and 88. So we've got 86, 87 and 88. It's 82% 88 and the others are in a 1:2 ratio. Now we know that percentages have to add up to 100, so 100 minus 82 is 18. And we need to split 18 into 3 parts so that we can have a 1:2 ratio. So 18 divided by 3 is 6, so it'd be 6 and 12. It wants the abundance of the 87, so that's 12. And then it wants us to calculate the AR. So if I look up at my little table, it's the sum of the mass times the abundance, the mass times the abundance, keep on adding up, the masses times the abundance, divide by the total abundance. Well, these were in percentages, so I'm going to divide by 100. So on your calculator, you want to put that in to your calculator, and I'm getting 87.76. It says give your answer to 1 decimal place, so 87.8. Electrospray ionisation is used instead of electron impact for proteins. Why? Suggest why. Proteins are very large molecules, and the difference between electrospray and electron impact is that electrospray does not cause fragmentation. So proteins are so big we don't want fragments. So protein does not fragment or break up and give us lots and lots of peaks.